Okay, so today we're going to be talking about this gradient intercept form, and we're going to be using our equation for that, which is y equals mx plus c. Now in this equation, our m here, okay, is always our gradient, okay, and our c here is always our y-intercept. Okay, so this allows us to make a start at graphing this an equation, which we're going to choose in a moment, on our set of axes over here. Okay, so let's just firstly choose our equation. I'll just put it to the side here so we can see there's a direct correlation. So we're going to choose an equation which is y equals 2x minus 1. So we can see we've got our gradient intercept form here, an equation, and we can see there's a correlation between our gradient and our y-intercept. So straight away we know that our y-intercept in this case is -1. Okay, so if our y-intercept is at -1, that means that our x value must be 0. So we can actually write this, we can say our y-intercept, okay, is -1, and the coordinates for the y-intercept, okay, so the coordinates, okay, are x0 and y -1. I'm going to just plot that over here on this axis. So we're going to number these off. Okay, so we're going to go 1, 2, 3, 4, -1, -2, -3, -4, 1, 2, 3, 4, and -1, -2, -3, -4. So let's find that point 0 and 1. So 0x we haven't moved, okay, in the x direction as well, but we've gone down 1, so we're at this little point here. Okay, so we've got our coordinate here. I'm going to give that a little label. Okay, we're going to do 0, 1. Okay, and that's our point, nice and close there. Okay, so we're halfway there. We've got a point on our line, but we need to know where's our line going to go. It's got a gradient. Okay, in this case the gradient is 2. Okay, so that allows us to write down here, m equals 2. Okay, now we also know that m is rise over run. Okay, so I'm going to put that as rise over run. Okay, so if the number 2 is rise over run, our 2 is going to be our numerator. We need to have a denominator of some description. So the denominator, if we turn 2 into a fraction, is actually 2 over 1. So our m value is now 2 over 1. Okay, if that's the case, that allows us, on our set of axes, to go and look for, okay, rise being 2, run 1. So I'm going to run 1 across. I'm going to rise 2 up. So we'll have a look at what that looks like on our graph. So we're going to rise over run, so run only 1 and rise 2, and we end up here. Okay, so we can see in that case if we've gone forward 1, our x value is increased by 1. I'm just going to actually put the coordinates here. So we've got a 1 here now. Okay, and we've risen 2 from, this should be -1 here. Okay, we've risen 2 from -1, so we've gone from 1 over the line of 0 for y up to 1 for y. So here we go, and new coordinates at 1, 1. We can also just grab a little ruler, draw a line between our 2 points. Okay, join up our 2 points. Okay, and then we've plotted our line. The last thing that remains is we need to actually label our equation for that line. So we've got access, we've got all the scale. We just want to say y equals 2x minus 1. Put an arrow at either end of the line because we know it extends infinitely in each direction. Okay, and we've used this gradient intercept form to plot this particular equation, y equals 2x plus 1, on our set of axes, and we've labelled the y-intercept, the second point, and we've labelled the equation. Okay, so you can try and log this up.